Hi everyone, and welcome to our video on the introduction to the half angle formulas. So the half angle formulas come right from where we left off on these power reducing formulas. Or if you're going in order, they come from those. So like the sine, let's just write the sine lowering power formula or show where it comes from. Okay, so this was our power reducing formula. So the sine squared, the lowers the power to have no squares in it. Well, what they do is they do a manipulation. They just say, well, let's let this be u over 2, which means that is also u over 2. Okay, so if they do that, then we get sine squared of u over 2 equals 1 minus cosine of 2 times u over 2 all over 2. Notice these 2's would cancel. Okay, so we've got just regular u now in the cosine function, and then to get rid of the square, well, they're going to square root. So square root both sides, and then plus minus. Okay, so that's where that comes from. So there it is. This is that. Okay, so just it's cleaned up. All right, the plus minus though depends on where this angle is. So the u over 2 is in some quadrant. So we choose plus minus, we need to choose which one based on u over 2 quadrant. Okay, which is in that box. Okay, and same deal with this one. And then tangent's a little different. Again, I would say tangent, most of the time you just need to do the sine over the cosine of the special angle, and it probably is easier. All right, but let's see how this also now works. All right, so let's use the half angle formula to find the exact value of each expression. All right, so in these problems, when they say use the half angle formula, they're saying this is the half angle. So that is the half angle right there, which is 112.5, which means I can instantly solve for u here. If I multiply both of those by 2, I would have u is equal to 225. And those are in degrees. Okay, so let's rewrite this. So I put that work there. Let's give it a little bit extra space. Okay, so what I like to do on these problems is say the u over 2. So I'm saying that whole 112.5 degrees was u over 2. And then I like to rewrite the whole formula out. Okay, so just directly like it is above. So plus or minus square root of 1 minus cosine of u over 2. And then immediately we're going to choose the sign. So 112.5, that's the degree that tells us the quadrant we're in. Well, 112.5 is somewhere over there. Okay, so it's not a quoted angle on the unit circle, but it's still on the unit circle. It's definitely in quadrant 2. And sine is positive in quadrant 2. So we should choose the positive on this. Now that we know the positive and we have the formula, we'll do our big old square root 1 minus cosine of u. So here's our u, 225 degrees, and then divided by 2. Okay, so there's the big setup. Now the rest of it is just the order of operations. Okay, so cosine of 225, that is right in the middle of quadrant 3. So that means that simplifies to be the square root of 1 minus negative square root of 2 over 2, all over 2. And then we just continue simplifying. Okay, so the minus and the negative would become a positive. So again, big old square root 1 plus square root of 2 over 2, all over 2. And then inside this fraction, we have a complex fraction. Inside the radical, a complex fraction. Notice our denominator is 2 down there. That's the only denominator we have in a small fraction. So that means we should multiply both the top and bottom of this fraction inside the square root by 2. And so as we do that, it gives us big old square root. The 2 distributes. So the 2 distributes. The numerator 2 distributes. So 1 times 2 is 2, then plus the square root of 2. And then down below, it is just 2 times 2, which is 4. Then we do have to remember square roots of fractions can break apart the numerator and the denominator like that. And the reason we do that is because we can do the square root of 4. Okay, so for our final answer, we're going to have the square root of 2 plus the square root of 2. So big square root, 2 plus square root of 2 over 2. There we go. Okay, so that was, and let's just rewrite what we did find. Sine of 112.5 is that as an exact value using the half angle formula. Okay, so if we plug it in a calculator, we'll go to decimal, but that's not what they want. Okay, so we're trying to get used to formulas is the main points of this, because obviously we could just plug it into a calculator. All right, anyway, let's go ahead and do this one too. So the cosine. Okay, so it says to use a half angle formula still. So either way, this part, let's put it a little further to the side. That is the u over 2. And then immediately we can get u if we multiply both the sides by 2. So we'd have u is equal to 9 pi quarters. Okay, so we have our u over 2 and we have our u. Now what we'll do is rewrite it like we did the last one. So I like to just set it up with a little bit more space where we say this is the same thing as our cosine of u over 2. And then we'll set up our formula, plus or minus big old square root 1 plus cosine of u over 2. Okay, so the cosine and the sine, again, are very similar, just a different with a minus versus a plus. All right, and then it's still just like the last one. Let's mark it in purple. I want to say, well, where is this? 9 pi over 8. Well, 9 pi over 8 is not a quoted angle on the unit circle, but it's there. It's a little bigger than pi, so it would be in quadrant 3. And so in quadrant 3, cosine is negative. So we should choose the negative symbol on this big old square root. And then now that we have it, we'll set up our big square root, 1 plus, and just like last time, we'll change the u. This is our u. So we'll change it into the 9 pi quarters. And then all divided by 2 still. Okay, so then we'll set this up and simplify. So we've got negative big old square root 1 cosine of 9 pi quarters. And we could do that. That is all the way around to quadrant 1 again. So that would be a positive square root of 2 over 2. And then still all over 2. Okay, so that's what that looks like. And then here's what's nice about these problems. Okay, so notice, or at least if you're doing them back to back. Okay, so if you didn't see this to the left, you just continue simplifying and working on it. But notice right here, I'm going to highlight it. So this in the black ink is the same as this. So that means everything under the square root would have simplified the same, and it eventually would simplify into this that I'm highlighting down below. So the only difference is that there's a negative in the front, negative, and then now let's write our final answer, square root of 2 plus square root of 2, all under that big square root like that, all divided by 2. That's it. Okay, so sometimes it's nice because the steps get recycled. Okay, so that's it. That's all done. All right, so if you do have any questions, please let me know. Otherwise, thanks for watching, and I'll see you again next time.